Hi everyone, we're now in video 3. In this video, I'm gonna show how we can build a Geogebra lag mechanism, basically a Geogebra model, and then how we can construct the SolidWorks model from this Geogebra model. The first step will be how we can generate the Geogebra model from a picture with the animation in Geogebra. So first, we need to find the picture we want to build in Geogebra. Here is an example. You can search the 4-bar linkage walker in Google and then click the first video. So this video is the one of the examples for 4-bar walker. And then so basically we want something like this in Geogebra, like a model with the animation. And then how we can get this picture is we can copy this lane, this Damshi, and then copy this and then search it in the Google as well. So we can find the pattern he made right here. And then we just take a screenshot for this pattern. I'm gonna zoom in and then move a little bit smaller. So take a screenshot. And then open your Geogebra right here. Please make sure you have installed the Geogebra in your computer. I also uploaded the installation package on our Google Drive, so you can just download that package and just install this. And then we need to import this file into the Geogebra, the picture. So it's right here, the edit and insert image from clipboard. Okay, so we have the picture in our Geogebra now. So before we do the model, I want to do something for the settings in the Geogebra. Okay, click right here, then object. We go to the preferences, graphics, and then uncheck this, show numbers. We don't need this. We don't need this as well. And for the grid, so personally, I want the grid disappear, so I just uncheck this as well. Then also, the other thing I like to do is keep the rounding to four places, and then where's the labeling? Yeah, here. So what I like is to make no new objects labeling. So in this case, when you create a new point or a new line, there will be no label in your this interface. It will make it cleaner. So it's just a personal option. And then so how can we model this walker in GeoGebra? The first thing we need to do is to label all the joints it has in this walker. So for example, I'll choose this point option right here, and then starting from the center point here. And then just basically just do wherever there is a joint. For example, here, here. You can zoom in more if you want more precise position for this joint. Cancel this. And if you want to move this view angle, it's better to go back to this move function and then just move it. Or you will create a new point just like I did. Right here. Go back and move again. Here's another one on the foot, basically right here. So we have down a half of it, and then we can do another part of this walker also right now. Okay, the crank for this part is here. Then just do all the joints one by one. This one. Okay. Okay, so this joint is a little bit tricky because you cannot see the position, but it's surrounding, I guess it it should be here. So like this position. Okay. Okay, now you have all the joints in your GeoGebra for this walker. And then the next step will be connect all these joints. So use this function, the line function, and then choose segment. Right here. Then I want to change the color of this link. I'll change it to green. And then also I want it thicker, so I can adjust the thickness right here. Okay, let's do this. Maybe thicker, a little bit thicker. Yeah. Then I'll connect these two joints as well. So for this one, I'll change another color, change it to red. And then these two joints, change it to a different color. I'll change it to blue. The final one right here, change it to brown. Okay. So you can see if you have checked the tutorial for the previous one, you should know how to build like a four bar linkage in GeoGebra. So this is basically the same. Um, if you cannot see the four bar in this picture, I will show you guys. So the ground link is actually between this joint on the very top to the crank here. This one, the center point. So I'll change it um, to this color. Okay, so this is actually our ground link. So we're building the static model right now. In the dynamic model, probably we don't need this ground link, but we need the length of it in SolidWorks anyway. So you can have it, or if you don't like it, you can just delete this. I'll keep this. Uh, I'll change a different color. Yellow. Okay. And then for this part, it's basically the same thing. So first connect this one and change the color to green. Just be consistent with the part with this part with the left part. Then this one is red. This one is blue. This one is brown. And then finally, the ground link is yellow. So here, we will have our static model. You can if you want some comment in the Geogebra, you can always do this. Like you can choose right here and then choose the text. So you can add a text box here and then just say static model. Click OK. I'll make the text a little bit bigger. Large. That looks good. Okay, so it's just something like this. Before we go to the dynamic model, there's one more thing I need to do is to choose this polygon right here and then draw the triangle for this output link. Then we can change the thickness of this triangle as well. Then do the same thing to the right side. Okay, it looks good. Now we're going to do the dynamic model. So first, we can build a line, parallel line, right here. Choose this one. Then there's a function called parallel line, parallel with the x-axis and also the center joint. And then draw a new joint, a new point right here. It depends. Move it to a little bit to the right. Okay. Then I'll draw another joint just for the angle. And then we need to add a slider. Okay, add the slider right here. Choose angle. Choose alpha. Then click OK. So this angle is to control the angle of the ground link. So what we need to do is to project this ground link to our dynamic model. Okay, we'll choose the angle and angle with given size. So choose this joint first and then the left one. So right here, we can choose the angle. And then we need to choose the angle alpha because it's changeable. So see, we're able to adjust the angle for the ground link. And then the next step is we need to move this ground link to the dynamic model. So we're gonna do circle and then choose compass. From the center joint, no, actually from the, choose compass again, from this joint to the center joint. And then move it to here, because this one is our center joint for the dynamic model. So click here, and then draw a line between this joint and this joint. Then we need to find out the intersect between this circle and this line. So here appears two new points, this two. And we can do our ground link right here. So this will be our ground link in our dynamic model. And we can also adjust this angle. And before we project another link to the dynamic model, what we need to do is to hide the unnecessary lines or circles like we don't want. I hide this one, This joint right here, also hide it. And this joint, these two are useless as well. So just hide it. Now we get a very clean picture, animation or whatever, right here. And then the next step, we can project the green link, also the input link. So basically do the same thing, but right here, because the input link is also rotating, so we need to add another slider later. Can do the campus first, and oh wait, I think yeah, I don't need a new joint. I can use the point right here. So make a new slider. Okay, I'll call it beta angle, and then beta. No, actually gamma, because we have used beta. You can see all the joints or the angles or the length right here. So we have used beta right here. So we need to use gamma. Okay, and then choose the angle with given size. Okay, choose here from here. Then input gamma. Okay, now we have a kind of line rotating to this ground link. So this can be our input link, also the green one. Then what we need to do is to do the campus again from the right joint to the center joint. Then put it here. Oh, we have already did this. So, oh, okay. So we don't need to do that. And then choose the line from the center joint to this joint. Then get the intersect between these two. Okay. And then just hide the things we don't want, just like we did. Uh, just like we did for the ground link. So this one, we don't want this. We don't need this circle as well. Then do the segment here. Change the color to green. Okay, so we have our input link. It's right here. The next step is to find the joint right here at the very right side, this one. So to find this joint, we need to use the campus function again, because right now we have already know the position of this joint. So we can just choose this joint, and then this joint, project it to here, and then also we know the position of this joint as well. So do this one again. And now we have two intersections um, in the dynamic model. So we want to show these intersections. And this joint is what we want for the last joint in the four-bar linkage. We just need to connect this one, change it to brown or red, brown. Then connect this one, change it to blue, and then hide those circles and the point. So we're gonna have a test. See, this is the 4-bar linkage, and it has the same dimensions with the static model. And now we still miss the triangle, so I'm gonna do the triangle right now. To construct this triangle, we need an angle, and also we need a length. So I'm gonna do the angle first. So we need to measure one of the angles in this triangle. For example, I'll measure from the very left to the right side and also this joint. And here we can see this new angle, epsilon, is right here. So what we need to do is choose the angle with given size and then choose this 2 point. And then input epsilon. Okay, so we have found this line here. You can see right here, but we still need the distance. So use the compass again. The compass, sorry. Locate this 2 joint and here. Then choose the line. Okay. So, and then make the intersections again. Now we can see this line is this joint is the foot right here. So we can do the polygon directly actually. Choose this joint, then choose here. And also hide the thing we don't want. This one, this one. We don't want this. This joint, we don't want this as well. So you can see, basically the right side of this walker is constructed. And now we just need to do the same thing for the left side. Oh, we can also show the trajectory of this foot. I'm gonna show how we can show the trajectory. There's a function called let me see, locus. Yes, this one. So choose this locus and um, choose this joint and also choose the input link, the slider of the input link. Then we will have the foot trajectory, the right side. Also, we can change the color. Let me see. I'll change it to gold, probably. Okay. So here we will have the foot trajectory for the right side of this walker. Okay, now we're gonna do the left side of the walker. For the left side, the input link is a little bit different that we can make because these two input cranks are fixed. They're fixed together. So um, what we need to do is to find this point based on these 2 points. So we can find the angle first from the static model. And then just project this angle to the dynamic model again. So choose these two joints. Then change the name. We can check the angle name right here. Change the name to eta. Then click OK. It's probably it's better to hide this joint, this point right here, because it will misleading us to find the new joint. I'll show you guys later, like why we hide this one. We can also hide the angles, so we don't need those angles as well. Oh wait, actually we need it for now because we need to draw a line between here to here, and then we can hide it. And then we just need to use the compass again from this point to this point. Okay, choose this point and then find the intersection between this circle and this line. So here, you can see this joint is pretty close to the joint I just hide. If you cannot see it, I'll compare it to you. So you see, if I unhide this joint, you cannot see it basically. So actually, there are two joints. That's why we need to hide this joint, because we need to use this joint, but not this joint. This joint we have right now has the geometrical relationship for this dynamic model. So that's why we need to use this one. And then we can hide the thing we don't want as usual. And then draw this line right here. Make it to green. So here we have the input link for the left side already. Then the next step will be finding the ground link for the left side. So we can do the same thing. Can measure the angle because the ground link is not moving as well. So we can find the angle first. Wait, we need to choose the angle with given size. Okay, and find the name. Okay, so it looks like we don't have this name for this new angle we just measured. So what I'm gonna do is I'm gonna object properties probably. And then we have the name right here. So we can copy this name directly and just do the same thing. This join, this join. And then paste the name right here. Okay, so the same thing, connect these two points and then hide this joint. Use compass again. Find intersection. And segment from this joint to this joint. Okay, change it to yellow, I think, yellow. Okay. And hide all the stuff we don't want. This joint as well. Okay, now we have the ground link for the left side. And you see if you move the whole walker, these two ground link will move together. That's what we want. Move it to a little bit flat. Okay, looks good. Then the the next steps will be um, the same as what you did for the right side. So I'm gonna find this joint as well. Use the compass again from this joint to this joint here. Then this joint to this joint here. Make the intersections. Use segment to connect this one first, and then this one. Change it to brown. And I also hide these two circles. Okay, the last step will be construct this triangle, which is also the same, just like what we did right here. So measure the angle first, here, here, and here. Okay, the name is lambda, so that's good. We can type it directly and go with given size here and here. Then lambda. Okay. And then just construct a polygon. Hide the angles also. And show the foot trajectory. This joint and here. Change it to gold. This is yellow, gold here. Let me change it to a thicker line. Change it to line thickness. Okay. And then if you want to put the animation on, you can right click this slider, the slider for the input links. And then right here, animation on. So you will see an animation for this walker. We can change this order that how the angle increases. Let me see. Here, can increasing. And the speed, if you want to change the speed, you can also do this right here. Move. We can also adjust the angle for our ground links. So just make sure your model is close to the static model. Yeah, and also, yeah, we can add another comment right here and call it dynamic model. Wait, okay. Change it to large. Okay, so right now we have the Geogebra model for this walker, and the next part will be how we can construct a SolidWorks model um, based on this dynamic model.